So this is how I solved problem number 6 for homework 3. The first thing I did was multiply both sides by x. So that gives you x cubed y prime plus x squared y equals y cubed. And we're going to want to save this equation here. And then the next thing I did was take that equation and divide both sides by x cubed. So when you do that, that gives you y prime plus y over x equals y cubed over x cubed. From here, I divided both sides by y cubed. So when you do that, that gives you y to the negative 3 y prime plus 1 over x y to the negative 2 equals 1 over x cubed, and I want to save this one as well. So now if you look at this equation up top here, that is written in the form y prime plus p of x y equals f of x times y to the n. And when you have something written in that form, you have u, which equals y times 1 over n. So in this case, if you look up here, our n is 3. So our u is equal to y raised to the 1 minus 3, which is equal to y to the negative 2. Okay, so let me move some things around. We found our u with this. We're going to keep this. Don't need this anymore. Okay. So we just found that our u equals y raised to the negative 2. So now, of course, if you do the math, u prime will be equal to negative 2y raised to the negative 3y prime. So now if you look at this equation up here, we can go ahead and plug in u for y raised to the negative 2 up here. So that's going to give us y to the negative 3y prime plus 1 over x times u equals 1 over x cubed. Now down here, we can plug in our u prime for this part of the formula up here, and when we account for the negative 2 being added, that comes to u prime plus negative 2x times u equals negative 2 over x cubed. So now I'm going to get rid of these, and I'll go ahead and move this up. And now we have our basic version of the formula. So step 2 is going to be find p of x, which is going to be right here. So p of x is equal to negative 2 over x. And of course our q of x is going to be right here. So we can go ahead and say q of x is equal to negative 2 over x cubed. So step 3 is going to be to find the integrating factor. So we have e raised to the p of x, which is negative 2 over x. Of course, the integration of that equals e raised to the negative 2 natural log of x, which is equal to e raised to the natural log of x to the negative 2. The e and that's going to cancel out, and we're left with x raised to the negative 2, which is our integrating factor. So let me go ahead and clear these. And now we have x is negative 2 as our integrating factor. So we can go ahead and write that where it needs to go. So you have x to the negative 2 u prime plus negative 2u over x cubed equals negative 2 over x to the 5th. And now this here is the derivative of our u over x squared, And we know that equals negative 2 over x to the 5th. So now we can find the integration of this side and the integration of this side. Of course, these are going to cancel out, and you're left with u over x squared is equal to 1 over 2x to the 4th plus c. And now I'm going to go ahead and clear this. We can move all of this up. And now we're going to do some simplification and common denominator on the right side. So when we simplify that, that comes out to u is equal to 1 plus 2x to the 4th times c all over 2x squared. Now if you remember, our u is equal to y raised to the negative 2. So we can go ahead and plug that back in. We have y raised to the negative 2 equals 1 plus 2x to the 4th c all over 2x squared. The next step would be to isolate the y. So when we do that, we're going to get two options, plus and minus, for the square root. It's going to be accounted for. So we'll have y is equal to negative rad 2x all over the radical of x to the 4th plus 1. And then we'll have the same thing except positive rad 2x all over the radical of x to the 4th plus 1. And don't forget, we had an initial solution of y of 1 is equal to 1. So then after that, you're going to have to plug this into this equation and this equation. And I already did that. And after you do that, you'll see that only this equation is true. So we can check that again real quick. Our initial condition was y of 1 equals 1. So 1 is equal to rad 2 times 1 all over rad 1 to the 4th plus 1. That equals rad 2 over rad 2, which equals 1. So check, this one works. Which proves that our answer to this problem is y equals rad 2 times x all over radical x to the 4th plus 1.